So there's been some design changes since the previous version to what I have now. And what I'm working towards is I want to have this piece here, this piece here, this piece that sits up front by the mag well and the trigger guard. Right now these are 3D printed plastic just for prototyping purposes. But eventually I want to have these made from aluminum. And I just think that's going to be better than having these done in 3D printed plastic. You know, the 3D printed plastic, it'll work, it's fine. But I really like the idea of a more refined design, something that's going to be more like a real firearm and it's going to have proper materials. So in doing that, you know, with the old version, let's take a look at this real quick. With the old version, the buffer tube was held in place with these 1/4 inch thick G10 rings that I machined. And they set into these side frames here. These, it's kind of like a mortise and tenon construction. There was little tabs that would stick out of these that would fit into slots in the side frame. And they're secure. They're held in there very well and they're very strong. And the buffer tube was secured in there by, this is kind of like scope rings. These could clamp down when I would tighten this M3 screw. So I'd stick the buffer tube in there, tighten the screws down, and it was good. And that design worked fine. But I really like the idea of something that looked more like a proper AR-15, where we could have a single piece here and we could thread the buffer tube into it. I also didn't like that I could not easily take out or slide out the takedown pin. If you had a malfunction in the weapon, you would have to unscrew this cover plate on both sides, and I had a hardened dowel pin in there. You'd have to drive that pin out, then you could rotate the upper off. Well, if you have a malfunction and you've got a round maybe that didn't fire, you don't want to be sitting there with tools and taking things apart. It just wasn't very safe. For prototyping purposes, so I could prove the design, it was totally fine, but I needed to refine that and work in a proper takedown pin. So those were the two design changes that I set out to make. And I accomplished that with a new embodiment here for the rear. What I did was I bulked up the piece here so that I could fit, it's going to be hard for you to see probably, but there is the spring rides in here and a detent for the takedown pin. And the takedown pin works just like it would work in a normal AR-15. And that spring is held in place with an M3 set screw. So I run the detent in, the spring, put a set screw in there, and now the rear takedown pin works like normal. So now you can quickly pivot the gun, the upper away from the lower, clear a malfunction, and you can do it safely. So that was one major design change that had to happen. Second, of course, was I wanted this as a solid piece that's tapped, 1 3/16 by 16. That's your threads for your buffer tube. So this piece now is a solid piece instead of the rings that clamp onto the tube. This is a solid piece that you thread the buffer tube into like you would do on a normal AR-15 lower. And then of course by doing that, it also afforded me the opportunity to put in this buffer catch right here. I didn't have this before, so when I would assemble the gun, I would have to push the buffer and spring in there. And then when I disassembled it, I'd have to be sure that this didn't come flying out. No longer. So this is exactly like a regular AR-15 would be. So those were the major design changes. And then for this version, I decided to cut my plates out of carbon fiber instead of the G10. This carbon fiber is about, I think, 25% lighter than G10, and it's about 50% stiffer. So this is a pretty amazing material. The downside to this is cost. This is a 1K, this is an aerospace grade carbon fiber. This isn't your cheap Chinese carbon fiber. I had this specially made for some other projects I was working on a few years ago, and I have a couple sheets left over. This is 1K, extremely tight grain, and I think this was like about $170 to $180 a sheet, and a sheet is 18 by 24. So it's not the cheapest, but I think it's going to be really cool for this because it's going to lighten it up and it's going to give me a little bit more rigidity. So let's take a look at the trigger I'm running in this thing. So on my previous version of the Quick80, I was running a mil-spec trigger. And worked fine, no problems. But I was talking to the guys that make the KE arms trigger. This is the SLT1. This is a drop-in trigger. And there are some distinct benefits with this trigger when you're dealing with an unorthodox type of a lower design, like say a 3D printed plastic lower. I know some guys are actually running 3D printed plastic lowers. Or, you know, in my case, I'm doing like a G10, or this particular one is a carbon fiber side frame. When you're dealing with materials that aren't as hard as aluminum and your trigger pins are getting set in those materials, well, with a standard mil-spec trigger, you've got a spring for the hammer, and it's independent of the trigger. And there's a disconnector too. And so what happens is when the trigger is moving and connecting up with all the parts, and it's being held here by the disconnector, there's a load there that the spring is applying, because the spring is under tension. And it's putting some load on these trigger pin holes, specifically this one here for the hammer. And over time, these holes will start to open up. And when you're dealing with especially a 3D printed plastic lower, you're gonna have some issues pretty quick. Even with G10 and carbon fiber, over time, those may start to open up a little bit. And then you have to run oversized pins, and that just buys you more time. Now, I think that with the carbon fiber in G10, it's gonna last quite a while, but for 3D printed plastic lower, I think it's almost a necessity that you run a drop-in trigger like this. And what's great about this one is there's no disconnector. So I think it's a 4.5 pound pull on this trigger, and it's a super crisp break. This is gonna be a pretty cool trigger. So I'm gonna drop this thing in here and I'm gonna see what it does. But again, I just really like the advantage that it has, because with the drop-in, those loads are being carried by this embodiment that the trigger sits within. So when you drop this thing in a 3D printed plastic or G10 or carbon fiber side frame like mine, the only load that these holes are taking is just the load to locate and hold this trigger in place. When the hammer is pulled back and cocked, all this spring tension and load is being carried entirely by this embodiment. So I'm gonna try this out. I think this is gonna be an awesome trigger for this style of gun, and we're gonna see what happens with it. All right, so I've got the prototype version 2 fully assembled, and I haven't put an upper on it yet. I'm gonna do that next, but the assembly of the lower is complete. So yeah, it came together really well. I didn't have any issues. Everything fit just fine. No worries there. So on this one I'm running, I just got some Magpul grips. Bruce over at Mr. Silencer gave me a pair of these grips. Thanks, Bruce. I like these. These are got a nice feel to them. They got a little cut out there for your thumb, which my machined ones, these are what I was running before, that didn't have that. These are a little bulkier too. Oh, one thing I forgot to mention too was, so one of the other design changes from the previous one to the new one is, I don't know how easy this is gonna be to see, but I'm running a steeper angle on the grip. I swung it more vertical by, I think it was about 7 degrees. This is a typical standard mil-spec AR rake angle here, and this one is more vertical. And it turns out that the angle that I cocked it on a 1911 grip, which these are, puts this angle here almost parallel to the lines, the horizontal lines of the gun. So better for if you're tucking it in short, right up to your shoulder. You're not having to cock your wrist like that. It's going to sit at more of a comfortable angle. So that was one change, and I'm going to stick with that design change throughout. It's definitely, they're all going to have this slightly, more vertical grip. It's not as vertical as what a lot of guys are running, like, really vertical. It's kind of in between. So it's a compromise. You get a little bit of best of both that way. All right, I'm going to do a weight comparison between a standard AR, regular aluminum, all aluminum AR lower, and then the Quick80. They're basically in the same configuration. The only difference is I do have a Praxis Precision grip on this one. It's aluminum. It's going to be a little heavier than, say, a plastic grip, maybe by like an ounce or an ounce and a half or so. But aside from that, these are, I would say, in nearly identical configuration. So here we have 1 pound 8.7 ounce, and then we take the Quick80 and we have 15.3 ounces. So about half a pound lighter on the Quick80, and you can feel it. It's almost like it's not even there. It's pretty crazy how light it is. All right, upper is in place. She's all together, and everything fit fine. What I'm doing for right now, the front takedown pin, I'm just using a hardened dowel pin. And I used to have these covers. Let me grab one. And they would fit there. So you'd put your pin in and these would retain the pin. But I actually found I had to drive this pin in. It's pretty stiff in there. I don't think it's gonna come loose. I mean, ultimately, you probably still want to have those plates on there, but I'm going to leave them off for now. I actually had to drift that pin in there pretty good, and what's nice is it's because all the tolerances on this, I've kept them really tight, and the upper to lower fit is good and tight. There's, like my first version, there's no play. Like, you don't have to run one of those AccuWedges or anything. Everything fits good. At least on this, the uppers I've tried. I've tried 3 different uppers, and they all fit great. You know, there's going to be little differences between uppers, but basically I think this is going to be a nice tight fit on anything. So yeah, there we go. It's ready to run. I'm going to take it out next week and put a few rounds through it. I think this is probably going to be the design where it stays at, minus maybe a few, moving some holes around just a couple thousandths just to get alignments exactly right. At that point, I'm going to switch over. All the plastic parts are going to go to aluminum. I'm going to have those milled for a 3rd and final prototype, test that, and when everything is good, then this design is going off to the ATF, and they're going to evaluate it, and hopefully I'll get a determination letter that says in the kit form that this is going to be offered in, it would not be considered a firearm in its kit form unfinished state. And once I get that determination letter, then it's off to the races. I'm going to start manufacturing kits, and you'll be able to build one of these yourself. It will take from start to finish with a kit ready to go. Just a few holes you have to drill. No special milling, nothing fancy, just basic hand tools and drill some holes. This kit should take about less than an hour to complete. And that's what's the beauty about the Quick80 is no special tools, and in an hour or so, you've got a fully assembled AR-15 lower ready to run.